Understanding hydrology is extremely important as it is the science that deals with one of the most valuable resources on Earth, known as water. Generally, this report intended to discuss and explain how hydrology works and helps people in everyday life.
The introduction to hydrology. Hydrology deals with the occurrence, movement, and storage of water in the Earth system. Hydrologic science comprises understanding the underlying physical and stochastic processes involved in estimating the quantity and quality of water in the various spaces and stores. Also, there are many pathways the water may take in its continuous cycle of falling as rainfall and returning to the atmosphere. It may flow to rivers and finally to the sea. The study of hydrology also includes quantifying the effects of such human interventions on the natural system at watershed, river basin, regional, country, continental, and global scale. When we say hydrology, it talks about the properties, distribution, and circulation of water on the surface of the land, in the soil, and underlying rocks. Topics commonly covered include urban drainage, water supply, wastewater treatment, river management, and coastal protection. The process of water circulating from precipitation in the atmosphere, falling to the ground, traveling through a river basin, or through the entire Earth system, and then evaporating back to the atmosphere is known as the hydrologic cycle.
The hydrologic cycle is also known as water cycle. It is the continuous process through which water gets purified by evaporation and transported from the Earth's surface through the atmosphere and returned to the land and the oceans. This happens through different concepts at different rates, but the core concepts remain the same. Take note, water vaporizes or evaporates from the ocean, liquidizes as clouds, moves over land, and precipitates. From there, it can reach the groundwater, vaporize again, or enter a stream or lake. It will ultimately find its way to return to the ocean, either by falling as precipitation, flowing with the river, or by moving slowly with groundwater. This hydrologic cycle is also a process that transforms heat energy. Heat is transported towards the poles of the Earth by water being vaporized or evaporated and then condensing, which releases heat. Without the water cycle, the climate would be much more frozen, and areas that are away from the equator would become inhabitable. A professional of hydrology is known as a hydrologist. Using different scientific techniques and analytical methods, hydrologists collect and analyze data to resolve water-related problems, such as natural disasters, environmental preservation, and water management. So, hydrologists rely on their understanding of how water interacts with its environment, including how it is circulated from the Earth's surface to the atmosphere, and then how it returns to Earth. The field of hydrology consists not only of the studying the natural distribution and circulation of water, but it is also concerned with the impact of human activities on water quality and with problems in water management. Water is used by humans for different purposes. In homes, water is used for drinking, cooking, cleaning, and bathing. Many industries require large amounts of water. In agriculture, water is required for the irrigation of farmland and livestock. Water available in dams is used to produce hydroelectric power. The human uses of water are endless. The following are some of the applications of hydrology. First, we have hydrology helps to calculate the rainfall. Also, it helps to calculate the surface runoff and precipitation. Designing bridges, sewers, irrigation schemes, and urban drainage systems. Also, it provides clean drinking water. It also helps to design dams for hydroelectric power irrigation or water supply. Real-time flood warning and forecasting, determining the water balance of a region, and agricultural water balance. It also estimates or predicts the flood, landslide, or drought risk. It also helps to analyze the impacts of antecedent moisture on the sanitary sewer system. Helps to predict geomorphology changes such as erosion or sedimentation. Also, it helps to manage agricultural productivity and other more. Did you know hydrology is amazing? Here are some facts. Of all the availability of water on Earth, only 1% of it is suitable for human use. Also, only 3% of the water available on Earth is fresh water, which is available for drinking. Precipitation can come about in the form of rain, sleet, snow, or hail. When the water evaporates into the atmosphere, it cools and condenses to form clouds through a process known as condensation. When the clouds become too heavy for collecting water, it releases through a process known as precipitation. Also, did you know 70% of the human brain is made of water? And lastly, the Earth's hydrologic cycle began about 3.8 billion years ago when rainfall on Earth forming oceans. Explaining hydrology further will be presented in the next slides.
Hydrology is the science that encompasses the study of water on Earth's surface and underneath the Earth's surface, the occurrence and circulation of water, the physical and chemical properties of water, and its relationship with the human and material components of the environment. Eventually, the hydrology questions include the transfer of energy, nutrients, solutes, contaminants, or sediments, as well as the water fluxes themselves. All aspects of the Earth's available water are studied by experts from many disciplines, and these experts of the field in studying of water are called hydrologists. Also from geologists to engineers, which includes of studying of how water moves from the Earth's surface to the atmosphere and then back to Earth, which to obtain the information needed to manage this vital resource. The scope of hydrology may define as the portion of the cycle from the precipitation to re-evaporation or return to the water of the seas. Applied hydrology utilizes scientific findings to predict rates and amounts of runoff or river forecasting, estimate required spillway and reservoir capacities. It also studies soil-water plant relationships in agriculture, also estimates the available water supply, and for other applications, it's necessary to manage all of the water resources. Sa madaling kasabihan, ang hydrology ay isang pag-aaral ng tubig na aalamin ang mga chemical components, properties at kung paano ang kilos o kaya ay ang pag-ikot ng tubig sa mundo.
The field of hydrology consists not only of studying the natural distribution and circulation of water, but it is also concerned with the impact of human activities on water quality and with problems in water management. The scientific study of the waters of the earth, especially with relation to the effects of precipitation and evaporation upon the occurrence and the character of water in streams, lakes, and on or below the land surface. The list of human uses of water is virtually endless. Sa kadahilan ng ang tubig ay isa sa pinakakailangan ng mga tao, kaya habang tumatagal ay sumusobra rin ang paggamit natin ito. Dahil sa dami o sa panghapong buhay na paggamit ng tubig, ito ay pinag-aaralan katulad na lamang ng industriya ng mga ininyero. Pinag-aaralan kung paano mas mayaangkop o mas mapapatibay ang mga estrukturang itatayo katulad ng mga dams.
According to the National Weather Service, the hydrologic cycle involves the continuous circulation of water in the Earth atmosphere system. At its core, the water cycle is the motion of water from the ground to the atmosphere and back again. Of the many processes involved in the hydrologic cycle, the most important are the following: evaporation, transpiration, condensation, precipitation, and surface or snow runoff.
The hydrologic cycle. The hydrologic cycle involves the continuous circulation of water in the Earth-atmosphere system. At its core, the water cycle is the motion of the water from the ground to the atmosphere and back again. Of the many processes involved in the hydrologic cycle, the most important are evaporation, transpiration, condensation, precipitation, runoff. Evaporation. Evaporation is the change of state in a substance from a liquid to a gas. In meteorology, The substance we are concerned about the most is water. For evaporation to take place, energy is required. The energy can come from any source: the sun, the atmosphere, the earth, or objects on the earth such as humans. Everyone has experienced evaporation personally. When the body heats up due to the air temperature or through exercise, the body sweats, secreting water onto the skin. The purpose is to cause the body to use its heat to evaporate the liquid, thereby removing heat and cooling the body. It is the same effect that can be seen when you step out of a shower or swimming pool. The coolness you feel is from the removing of bodily heat to evaporate the water on your skin. Transpiration. Transpiration is the evaporation of water from plants through stomata. Stomata are small openings found on the underside of leaves that are connected to vascular plant tissues. In most plants, transpiration is a passive process largely controlled by the humidity of the atmosphere and the moisture of the content of the soil. Of the transpired water passing through a plant, only 1% is used in the growth process of plant. The remaining 99% is passed into the atmosphere.
Condensation is the process whereby water vapor in the atmosphere is changed into a liquid state. In the atmosphere, condensation may appear as clouds or dew. Condensation is the process whereby water appears on the side of uninsulated cold drink cans or in bottles. So for example, you bought a drink from a convenience store. So when you take the drink out of the fridge, it suddenly becomes foggy or sometimes it forms water droplets. It's not because your drink has holes in them. It is because the bottle itself is exposed to a new temperature. Condensation is not a matter of one particular temperature, but of a difference between two temperatures, the air temperature and the dew point temperature. So at its basic meaning, the dew point is the temperature where dew can form. But actually it's temperature that, if the air is too cool to that level, the air becomes saturated, so any additional cooling causes water vapor to condense. Foggy conditions often occur when air temperature and dew point are equal. Condensation is the exact opposite of evaporation, since water vapor has a higher energy level than of that liquid water. So when condensation occurs, the excess energy in the form of heat energy is released. So this release of heat aids in the formation of hurricanes. So condensation is quite a powerful tool when it is exposed to excessive amounts of energy, because this can be a catalyst of sorts for hurricanes or tropical depressions. Precipitation is the result when tiny condensation particles grow too large, through collision and coalescence, for the rising air to support and thus fall to the earth. Precipitation can be in the form of hail, rain, snow, or sleet. So when particles get too heavy for air to carry, it falls down to the earth due to gravity. And forms of precipitation can occur in many forms because it depends on the climate of the country, or the place rather. So lucky for the Philippines, we only experience precipitation in two ways: by rain and sometimes by hail. Because if the Philippines were to be exposed to snow, amendments on the National Building Code and the National Structural Code should be investigated to support the load of snow and other precipitation factors. Precipitation is the primary way we receive fresh water on Earth. On average, the world receives about 38.5 inches or about 980 millimeters of water each year over both oceans and land masses. So precipitation can provide us with more water than we have to dig it up somewhere to get groundwater. So for the last part, it is runoff. Runoff occurs when there is excessive precipitation and the ground becomes saturated, meaning it cannot absorb any more water. This leads to the formation of rivers and lakes because they are the results of runoff. There is some evaporation from runoff into the atmosphere, but for the most part, water in rivers and lakes return to the oceans. If runoff water flows into the lake only, meaning no outlet for water to flow out of the lake, then evaporation is the only means for water to return to the atmosphere. As water evaporates, water impurities such as salt and other dirt are left behind. The result is the lake becomes salty in the case of the Great Salt Lake in Utah or the Dead Sea in Israel. Because when water evaporates, it separates from the impurities because the impurities are in fact heavy and cannot be carried by air. Meaning, as time passes by, lakes become more salty because of the impurities left behind from the water cycle. Evaporation of this runoff into the atmosphere begins the hydrologic cycle over again. Some of the water percolates into the soil and into the groundwater, only to be drawn into plants again for the transpiration to take place. The following is the development of hydrology according to history. So the art of hydrology and hydraulics has been ever evolving since ancient times, mainly in countries such as Pakistan, China, and in Egypt. And in Egypt, the Nile floods formed basis for a large-scale, successful agricultural system. Irrigation's history can be tracked back as up to 5,000 years, the proof of which is in the remains of the world's oldest dam built between 2950 and 2750 BC, found near Cairo. This is from Bizwer, 1970. In nearly 3000 BC, gauges were installed to measure the flow of the Nile. So even back then, gauges were used to measure the flow of water, hence the start of hydrology. The next stage is when Aristotle from 384 to 322 BC explained the mechanism of precipitation. In Aristotle's model, the moisture surrounding the earth is made to evaporate and rise by the sun's rays. The exhalation of water is vapor, air condensing into water is cloud, mist is left over when a cloud condenses into water and is therefore rather a sign of fine weather than of rain. So he understood the difference between water vapor, which is a colorless gas, and the small droplets that form clouds. The moisture is always raised by the heat that descends to the earth again when it gets cold. When the water falls into small drops, it is called drizzle, and when the drops are larger, it is rain. As progressive as he was, Aristotle's model became another foundation for us to have a more broad understanding of the hydrologic cycle. Then Da Vinci from 1452 to 1519 gave the better understanding of flow in open channels. Palissy then, from 1510 to 1590, stated that rainfall was the only source of water of spring and rivers. Da Vinci and Palissy gave the concept of the water cycle in the 15th century. So the Renaissance era was not only an era for the development of art. The development of science was also very much prevalent in this time, even the art of hydrology, because they gave us more understanding as to the process of how water goes up, goes down, and starts all over again.
Going back to the 17th century, the modern science of hydrology began with the studies of Perrault, Marriott, and Halley. Perrault presented the concept of measuring rainfall by knowing the drainage area and employing the water balance technique, while Halley measured the evaporation rate of the Mediterranean Sea. The 16th century saw numerous advances in hydraulic theory and instrumentation. Examples include piezometer, pitot tube, Bernoulli's theory, and the Chazy formula. Finally, the significant advances were made in groundwater hydrology and surface water measurement during the 19th century. During this time, the capillary flow equation, Darcy's law, and the Dupuy theorem were developed. Since then, the science of hydrology has been constantly evolving. This has been a report on the introduction to hydrology, its overview, cycles, and history. The following slide include the references used by the group. Thank you for listening.